What's up? This is take 2 because I have OBS error and I did stream for 1 hour but the audio was off for 1 hour so it's doing the same thing again. Right. Let's go. At first, I want to compare Radeon RX 9070 AMD Radeon and NVIDIA GeForce RTX 5070 Ti. And at first the price is different, so it depends on how much of the spec or function you want and how much you want to pay for the function. I think that's a huge thing. And also for if you want the PC for gaming or PC for AI image generation or some text related things, I think that makes a difference. So at first I jump into conclusion. For gaming, Radeon AMD is good for now, and for AI and other things, AI related things, NVIDIA will be good in future. That's in future. That's maybe because the software is not made for the 5070 Ti yet, and maybe will be. So far AMD is really good, but in future NVIDIA will be better. I think that's the things. And let's check some specific things. Both has 16GB memory, and that will help enough for gaming and AI things. And I want to know more about this, the GDDR6 and GDDR7. That might be the difference, and that might help. I don't know how, but somehow I want to run that. And memory bandwidth, AMD 9070 is 512 gigabyte per second, 512, and NVIDIA 5070 is 768 gigabyte per second, 768, 512, 768. So that's a huge difference. And also prices, that's really important. 600 AMD and 750 for NVIDIA. So I think it will be, it's not exactly the same level of the price. NVIDIA is, this one is higher, so it's really difficult to compare, but so in other words, NVIDIA is cheaper. I think that's the thing. And performance. In game benchmark, both GPU deliver exceptional performance at 4K resolution. Radeon 9070 XT demonstrate 42 performance increase at 4K ultra setting compared to its predecessor RX 7900 GRE. So huge upgrade than the past one in same company. And GeForce RTX 5070 Ti offers substantial gain over the previous RTX 4070 Ti. The past product with its enhancement in ray tracing and AI-driven upscaling technology. I think that's the important things because I heard of that these kind of things. AI-driven upscaling technology is AI recognize the object, for example, a human and desk and chair recognize the object and draw the object. That improves like less memory and higher quality, for example shading and maybe some contrast, these kind of things. And then next, in title like Monster Hunter Wilds, benchmark suggests that both GPU perform admirably with the RTX 5070 Ti, the NVIDIA slightly edging out in ray tracing scenarios, while AMD RX 9070 XT showcase strength in traditional rasterization performance. So traditional things is AMD is better, and NVIDIA is better at ray tracing. Okay, move on. Features. Yes. AMD Radeon RX 9070 XT FSR4, the latest iteration of AMD Fidelity FX Super Resolution, providing enhanced AI upscaling for improved performance and image quality. FSR4 LDNA RDNA 4 architecture delivers double the performance per compute unit over RDNA 2. You know RDNA, so alright. I don't know what's this. Double performance per unit. Oh, so this is a unit, and this is a number of the unit, maybe, and with advancement in ray tracing. So it was 2, but now you can use 4. That's great. I'm not sure. NVIDIA GeForce RTX 5070 Ti DLSS4, NVIDIA's deep learning super sampling technology, now in its fourth iteration. Offers superior AI-driven upscaling and performance boost. Neural shaders enhance real-time rendering capability, providing more realistic graphic and writing effect. That's great. I don't have knowledge how these different and how far it's good or better, and I'm not sure how to compare them. But okay, was doing great. I think that's the impression. Right. Now I'm checking stream. It's really on the sound. I'm not sure how. Right. Okay. My voice is on stream, and it wasn't on last time. And talked 1 hour in vain. So. Right. Right. Good. And move on to power consumption. Both GPU have similar thermal design power TDP rating, both 300 watt. This indicates comparable power efficiency, though real-world consumption may vary based on system configuration and workload, pricing, and availability. Radeon 590, almost 600 $, starting March 6, and RTX NVIDIA 5070 Ti priced at $750, released in February 2025. I hope you can get that. Let's hope that. Conclusion. Both AMD Radeon RX 9070 XT and NVIDIA GeForce RTX 5070 Ti are formidable contenders in high-end GPU market. The NVIDIA RX 9070 XT offers a compelling value proposition in a lower price point and strong performance, particularly in traditional. I said NVIDIA. I said AMD. Very confusing. AMD Radeon 9070 is good at traditional rendering task. So AMD Radeon is traditional things strong, and on the other hand, GeForce NVIDIA RTX 5070 Ti provides advanced features like DLSS4 and neural shaders, which may appeal to users seeking cutting-edge technology, new technology, and superior ray tracing performance. The choice between two will depend on specific preference, budget, consideration, and particular application or game you intend to run. Right. Let's check this. And this is a comparison. And this compares the frame rate of the when playing game. And as a conclusion, AMD is really great. and 5.0 generation is not optimized yet. So 5 NVIDIA 5.0 generation, 4.0 generation, almost same. That's the conclusion of this. For example, this is forwards. Or for this one, it's varies. Like, I think these three almost same, and 4070 will be higher than the other, but almost same. And I think that's really good enough. Ryzen 5 and RTX 5070 140 to 50, AMD, the center one is 9070, it's 160 to 70, and this one the 4070 is 150 to 60. And AMD is best in the three. For this, AMD wins Rebit. Everything 3 is over 80 FPS, and AMD is 90, so Rebit slightly better. I think it's for most title, AMD slightly better. Cyberpunk, almost same, 120 on average. But maybe the other NVIDIA 5070, 4070, 110 might be. So AMD 9070 will be best. For this, the AMD best. Right. Right. So generally speaking, the AMD Radeon is good for gaming, better than NVIDIA. Not only performance but also the price. So for gaming use, NVIDIA will be expensive, so AMD will be good for gaming. Right. I realize that I realize I forgot to change the title. This one. Okay. Now I realize that.
切ったぞ。古典藩は死んだ。あやつの兵も敗れた。明日幾千もの武士が。
Time. Right now, moving to next. And for AI and video generation, as well as 3D rendering in Blender, the NVIDIA GeForce RTX 5070 Ti is generally the better choice over the AMD Radeon RX 9070 XT due to the following factors. And AI image in video generation. Oh, here compare NVIDIA and AMD. NVIDIA 5070 Ti is features tensor cores that accelerate AI processing, benefiting tools like these Stable Diffusion, Runway, ML Config UI, and Animate Diffusion. And NVIDIA supports CUDA. I'm not sure how to read CUDA or CUDA, and TensorRT, which optimize deep learning model interface. In model inference, DLSS4, and neural shaders. Improve AI-driven upscaling and image quality. And NVIDIA compatible with popular AI framework like TensorFlow and PyTorch. I think these are really important for AI designer, programmers. So for using AI frameworks like TensorFlow and PyTorch, NVIDIA is better choice for that use. On the other hand, AMD Radeon RX 9070 XT lacks dedicated tensor cores which reduce AI-specific performance. So yeah, that's the difference. AI image generation lacks and AMD lacks tensor core, and AMD Radeon uses FSR4. This is difficult one. Fidelity FX super resolution. Fidelity FX super resolution for upscaling, but less effective for AI workloads. So AMD is really good at gaming, but not so great for AI image and video generation compared with NVIDIA. Like not optimized for AI image video generation. But I think it works well, but NVIDIA is better in that field. For gaming, AMD is great. And AMD, some AI frameworks have limited support for AMD GPU due to OpenCL instead of CUDA. Limited support. I think that's very important for someone want to use graphic board for AI image and video generation. So these software support kind of things are really important to know before getting it. So RTX 5070 Ti wins for AI generation due to CUDA, Tensor Core, and broader software support. I think these kind of things is really hard to know, but when after getting the some PC or graphic board, I want to do this, but that software or service doesn't support this my PC graphic board. When that happens, I'm gonna cry. So I want to learn about the AI generation things. So I'm thinking about getting NVIDIA. Maybe pricey though. So next topic, 3D rendering. For example, Blender, Unreal Engine, 3ds Max, Maya, NVIDIA, AMD. At first, NVIDIA RTX 5070 Ti supports CUDA, OptiX, and RTX acceleration, significantly boosting render times in Blender cycles and Octane render. Faster performance in ray tracing heavy 3D rendering tasks. Works well with Unreal Engine 5, 9, I don't know, 9 and Lumen technologies. AMD Radeon RX 9070 XT use HIP. This is also difficult one. Heterogeneous computing interface for portability for Blender rendering, but it's slower than CUDA OptiX. 3D rendering, NVIDIA faster. Because of these things, HIP and CUDA OptiX. For Blender, AMD Radeon, good traditional rasterization performance, but lacks AI enhanced acceleration like RTX cards. That lacks AI enhanced acceleration. So RTX 5070 Ti wins for 3D rendering due to CUDA, OptiX, and better ray tracing performance. But I'm saying it's only specific for 3D rendering with this software. So if you want to buy PC for pro gaming, you don't have to choose NVIDIA because AMD is really good for gaming, really optimized for gaming released now. So that's a choice. What you want to do and what you need to get. Next one. Three. AI assisted video editing. Like, for example, DaVinci, Resolve, Adobe Premiere, After Effects. AI assisted video editing. That's maybe you already know the result. At first, good result, RTX 50 Ti wins for AI enhanced video editing because it's AI enhanced, right? So NVIDIA, let's go to comparison. NVIDIA RTX 5070 Ti NVENC encoder provides better hardware accelerated video encoding and decoding. CUDA acceleration improves AI-based features like auto-reframing, denoising, and color grading. Oh, auto-reframing, that's great. AV1 encoding is superior for streaming and exporting high-quality AI-generated video. I'm not sure how this works. AI things for streaming. Maybe remove some noise and the color grading thing, smoothness, and make some high quality and natural, but its efficiency is really good. I think that's the things. On the other hand, AMD Radeon RX 9070 XT use VCE video coding engine, but it's not as optimized as NVIDIA NVENC for professional video editing. I think it works really great, but not when compared with NVIDIA, not optimized. I think that's the thing. Both working well, but and continue. AMD Radeon RX CUDA based acceleration in DaVinci Resolve and Adobe Premiere. I see. So as a result, RTX 5070 Ti wins for AI enhanced video editing. So as a recommendation, if your focus is AI image or video generation, 3D modeling like Blender, and AI powered video editing, the NVIDIA RTX 5070 Ti is better choice due to CUDA, Tensor Core, DLSS4, and superior video editing and video encoding support. So software is optimized for NVIDIA. I think that's really important to know. the many company optimize to NVIDIA. And I think that kind of thing continues from now on. And maybe these kind of editing software is optimized for Intel rather than AMD. But you need to choose. And continue. If you prioritize gaming, traditional rasterization performance at a lower price, AMD RX 9070 XT is strong contender. But for AI and 3D works, go for NVIDIA. Right, that's right. So AMD and AMD Radeon is very good for the price. So that's a choice. And both doing great, so I think both are great. And next, I want to move on to the CPU. I'm getting ready and checking. Checking the screen. XT is strong, right? And now moving into CPU. Let's compare CPU. When evaluating CPUs for 3D rendering and 3 AI generation tasks. CPU for 3D rendering, AI generation task. AMD Ryzen 9, Intel, AMD Ryzen 9950X 3D, 9950, and Intel Core Ultra 9 are both good option, and let's compare. Architecture overview. AMD, Intel. AMD at first, Ryzen 9 9950 3D. The difference is the threads and cores and threads, and also base and boost clock, and also cache and watt. And I thought the AMD is single core faster and Core Ultra Intel is more cores. That's good for doing multitask, like different application, for example, gaming, streaming, and some other softwares, audio softwares, and like multitask things. That helps the Intel's 24 cores might help for that kind of task. I think that's the things. And when, for example, rendering video only, and the higher speed is better, so AMD will be good for single task. I think that's the thing. And move on to this topic. And performance in 3D rendering. In professional 3D rendering application, the Ryzen 9 9950X3D has demonstrated superior performance. For example, bullet benchmark. Ryzen 9 outstanding outperformed Core Ultra 9 approximately 17%. That's huge. Corner render. Ryzen better 50%. Next, K shot. Ryzen better 11%. So on average, like 10 or 15% better performance on rendering, 3D rendering. These gains are attributed to AMD's higher core count with simultaneous multi-threading and substantial cache size. That AMD has 144 cache, 144 megabyte, and Core Ultra 36 megabyte. Cache size, multi-thread rendering task. Right. Performance in AI generation task. For AI workloads, both CPUs offer robust Intel Core Ultra 9 features an integrated NPU, neural processing unit, designed to accelerate AI tasks. AMD Ryzen 9950X3D, while lacking dedicated NPU, its higher base and boost clocks combined with increased cache contribute to efficient AI data processing. Specific benchmarks for AI performance are limited, but the presence of an NPU in Intel CPU suggests potential advantage. You need to know the potential advantage in an AI-specific application. It's not, might be not released yet, but optimized software application will be released. So, and next, power efficiency. Core Ultra 9. Core Ultra 9 operates at lower TDP, 125 watt, compared to the Ryzen 9, 170 watt. Intel 125, AMD 170, indicating potentially better power efficiency. So Intel is better power efficiency. As a conclusion, for 3D rendering task, AMD Ryzen 9 9950X3D stands out due to its higher core count with multi-threading and large cache, offering significant performance benefits in AI generation tasks. The Intel Core Ultra 9 may have an edge due to its dedicated NPU, although real-world advantages depend on software optimization. That's really important to know. Software is optimized. Your software is optimized. Consider your specific workload requirement and software capability when making a choice. And let's check the video.
So in this video, we're gonna be bearing in mind a put together neural processing unit. Probably a lot of them would not have. Also, we're gonna be taking a look at as much as possible as AI, 3 AIs or 1 mini. Bearing in mind a couple of themes as you watch. The first theme is AI and the second theme is overclocking. On the AI theme, the video was put together by 3 AIs, O1 Mini, O1 Preview, and Perplexity's Claude Sonnet 3.5. O1 Mini did most of the research, O1 Preview put together the script, and Perplexity's Claude Sonnet 3.5 did some fact checking. Also, we're going to be taking a look at as much as possible as AI performance because the Ryzen 9 9950X and the 285K both have NPUs or neural processing units. These are designed to help with AI, but most of the reviews you'd have seen over the last couple of days will not have covered AI, and probably a lot of them would not have found a lot of difference between the new and the old. We're going to be using data from Geekbench 6, which has got some built-in capabilities to look at AI performance, and we're going to be trying to see if there's any difference in AI performance that we can find out. On the second theme, overclocking, this one is of particular importance to me. We're here on the Ryzen 9 9950X webpage, and I've shown this before, and you can see here that AMD tells us that the fastest memory speed is 5600, and we also know that with Intel they have got for the 285K a faster speed which they state as 6400 megahertz. Now when it comes to testing, almost all the tests were done at a massive overclock of 8200 megahertz for Intel, and almost all of them were done at 6000 megahertz for AMD.
Hey tech enthusiasts, welcome back to the channel where we dive deep into the latest hardware to help you make informed decisions. Today we're putting 2 flagship CPUs head-to-head, the Intel Core Ultra 9 285K and the AMD Ryzen 9950X. We'll explore their performance metrics, stability considerations, pricing, and ultimately determine which one offers the best value for your needs. Let's get started. Introduction to the contenders. First up, we have the Intel Core Ultra 9 285K, launched at $590. It's Intel's latest high-performance processor, aiming to surpass the previous Core i9149K. On the other side, the AMD Ryzen 9950X comes in at $649, representing AMD's top-tier offering designed to deliver exceptional performance across various workloads. Evaluating performance with Geekbench data. To evaluate these CPUs, we've conducted extensive analysis of benchmarking data on Geekbench. We identified the top 20 single-core and multi-core scores for each CPU from a random sample to calculate reliable mean and median values. How do the Intel CPUs compare?
Let's start by comparing the Intel CPUs. The Core Ultra 9 285K shows an improvement over the Core i9 14900K in both single and multi-core performance. Specifically, there's about a 5% increase in performance in single-core scores and roughly a 2% increase in multi-core scores. While these gains are measurable, they may not represent a cost-effective leap for users that are already using the very capable 14900K. Now let's take a look at the AMD side. The Ryzen 9 950X demonstrates a more substantial improvement over the 7950X, with approximately an 8% increase in performance for main single-core performance, and the multi-core performance sees a modest gain of about 0.5%. This suggests that the 950X offers a more noticeable enhancement in tasks that rely heavily on single-core performance, such as gaming and certain applications.
What are the real-world implications? So what do these numbers mean in practical terms? Intel Core Ultra 9, 285K. The incremental improvements suggest that if you're upgrading from an older generation, you'll experience better performance. But the gains over the 14900K may not justify the upgrade for everyone. AMD Ryzen 9 9950X, the significant single-core performance boost makes it an attractive option for users seeking better responsiveness and performance in single-threaded applications. Memory overclocking and stability. A critical aspect of CPU performance is how well it handles memory overclocking. Intel's approach. Reviewers have been testing the 285K with memory speeds up to 8,200 MHz, which is a substantial overclock from the official support of 6,400 MHz. While higher memory speeds can enhance performance, they can also introduce system instability. Indeed, some reviewers have reported stability issues at these massively overclocked speeds, which could impact your user experience. AMD asked reviewers to use memory speeds of 6,000 MHz for the Ryzen 9 9950X. This strikes a better balance between performance and reliability, ensuring stable operation without pushing the hardware beyond its optimal specifications. Price to performance considerations. When investing in a high-end CPU, it's essential to consider the value you're getting for your money. Why I'm recommending AMD Ryzen 9 9950X? After analyzing the data and considering real-world usage, here's why I recommend the AMD Ryzen 9 9950X, significant single-core performance boost. The 9950X offers an appreciable increase in single-core performance, which can lead to better performance in gaming and applications that aren't fully optimized for multi-threading. Stable and reliable operation. AMD's guidance on memory speeds provides a better balance, so you get optimal performance without sacrificing system stability. This is crucial for professionals and enthusiasts who need a dependable system. Balanced multi-core performance. While the multi-core performance gains are modest, the 9950X still delivers top-tier performance suitable for demanding multi-threaded workloads like video rendering, 3D modeling, and data analysis. Future-proofing. Investing in the 9950X provides a degree of future-proofing, ensuring that your system remains capable as software continues to evolve and take advantage of higher single-core performance. Conclusion. In conclusion, both the Intel Core Ultra 9 285K and the AMD Ryzen 9 9950X are formidable processors. However, the Ryzen 9 9950X stands out due to its more substantial performance improvements and stable operation at recommended settings. The combination of enhanced single-core performance and reliability makes it the better choice for most users, especially if the pricing fits within your budget. Thank you for joining me in this deep dive into these impressive CPUs. If you found this analysis, use compare.
Let's start by comparing the Intel CPUs. The
So, what do you think? What's your choice? My impression is AMD is this Ryzen 9 9950 3D is optimized all the things or upgraded all the things, and I think that's the best choice for now this year. And maybe in future Intel will be better, like next year, next year. But now today, Ryzen 9 will be better. So I need to know about the real world advantages. Depends on software optimization. That's a really serious thing. I don't want blue screen anymore, and I don't want to replace. So, what's your choice? I'm thinking CPU, Ryzen, and the graphic board, NVIDIA. How do you think? And I still don't know, but for graphic board 16GB will be some benefit for AI generation, like video, audio, image generation, or text things. So 16GB of graphic board GPU will be some key change, right? I start to feel that for AI 16GB, everything good point, maybe something enough for personal use. And I feel 12GB, it works well, but in future we need a little bit more. It's possible, so I feel sad when I have 12GB of graphic board and in future I need to upgrade because of 4GB. That's what I'm thinking. So what's your thought about the CPU, Intel, AMD, graphic board, NVIDIA, AMD? What's your choice? And also I never want to see the blue screen anymore. And how was your blue screen recently? Write on the comment and share your combination Intel, AMD, NVIDIA, AMD, your combination and your personal idea and also general idea. Like personal thing can be mine is okay, but someone has some trouble and this kind of happens. So, and I have problem, but the other one have no trouble, and then you pick the bad one. So I feel like it's a kind of lottery, like picking one, and okay, you are lucky, so your PC is safe, and I feel sad for you. Blue screen. I think that kind of thing happen. So what I want is a stability. It's safe, no blue screen, and no fire from the PC, and stable for years. I don't want to change PC for long. I don't want to change things. I want to use the same thing for long. So it's better you buy the product. You can have the refund if there's some problem, and maybe 1 year or 3 year. These kind of things might be really important. Right. Let's move on to next topic. Next topic is how important is a CPU compared to GPU? Okay. How important is a CPU compared to the GPU? The importance of CPU versus GPU depends on the type of task you are performing. So it's up to you, and always not want to pay too much for something we do not use. So if you use for this price will be great. Like this price for this function, that's not good. And let's go for AI image and video generation. For example, stable diffusion, animate diff, config UI, runway, ML. GPU is much more important because AI model rely on VRAM, CUDA cores, and tensor cores for processing. The RTX 5070 Ti will be the key component in the performance, and CPU difference will have minimal impact in most cases. So I'm thinking about this 5070 Ti. So I'm using this as an example of graphic board GPU. And for AI image generation, CPU difference will have minimal impact in most cases. However, the CPU affects data preparation, model loading, and some pre-processing steps. A faster CPU with more cores helps avoid bottlenecks, especially in workload with multiple tasks running simultaneously. Next, for 3D model. That was AI image video generation, and next is 3D modeling and rendering. Both CPU and GPU are important, but GPU has more impact on real-time viewpoint performance and final rendering speed. GPU handles rendering acceleration, CUDA OptiX, and RTX ray tracing. GPU acceleration, GPU Core Ultra 7 or 9 is important for physics simulations, complex geometry calculation, and multi-thread rendering tasks, like CPU-based rendering in Brenton servers. I do not know that. Oh, I thought GPU could handle these simulation, but physics simulation, complex geometry calculation. Oh, that's different. I didn't know that. That's good to know. And next topic. For video editing, for example, software like DaVinci Resolve, Premiere, After Effects. GPU is more important component because modern editing software uses CUDA and NVENC hardware acceleration and AI-powered effects. CPU helps with encoding, decoding, and effects processing. But the difference between Core Ultra 7 and 9 is small unless you use extremely heavy effects. So I'm not sure. I think it's fine for me to use 7. For gaming, GPU is far more important unless you play CPU-intensive strategy games. Oh, I don't know that. CPU-intensive strategy games. Maybe many things moving like strategy kind of things game. Unless that GPU is more important. Upgrading from Core Ultra 7 to 9 has small effects on FPS compared to upgrading the GPU. Yeah, that's what I predicted. Next. Core Ultra 7 versus Core Ultra 9. Both with same graphic board, GPU RTX 5070 Ti. Oh, that's the comparison. The core number of core is different. Core Ultra 7 16 core, Ultra 9 24 cores. Oh. But base clock is Ultra 7 is faster. But more core at the Ultra 9. That's data is really hard to tell how it affects in real world. And move on. Comparison. For AI generation and 3D modeling, the difference is small because GPU matters more. Core Ultra 9 may help with multitasking, but won't significantly speed up AI processing. So bottleneck will be GPU for AI generation and 3D modeling. Next, for video editing rendering, Core Ultra 9 is better for multi-threaded workloads, but Core Ultra 7 is already strong enough for most users. So both are good enough. For gaming, almost no difference in FPS because RTX 5070 Ti is the main factor, so graphic board is a bottleneck, and better GPU makes better result. Not depends on the CPU. Conclusion. If you only do AI image, video generation and 3D rendering, Core Ultra 7 and RTX 5070 Ti is great choice because AI depends more on GPU. If you also do multitasking, CPU rendering or heavy video editing, Core Ultra 9 is better, but not big difference for AI user. I'm sure. For what Core Ultra 9 is used, or maybe more stability like for professional use, and you don't want to crash on some streaming, maybe safety for your mind. that might be the thing in real world. So if you want to pay more for CPU, it's better to pay more for GPU, and that will help more, right? I think that's the things. And move on. Final recommendation. Best balance of price and performance for AI 3D users. Core Ultra 7 RTX 5070 Ti. Best high-end option for multitasking and CPU rendering. Core Ultra 9 RTX 5070 Ti. Multitasking. Maybe using some 3D modeling, and on the other hand using the AI things generation. And I think my mind is not that multitask, so I think it's fine with Core Ultra 7 because my brain is the bottleneck for that. I think that's the thing. If your brain is optimized for enough for Core Ultra 9, that would be great. Like thinking about 3D modeling and like code things, and both at the same time, like using 2 mouse and 2 keyboard. That's a great thing. So I think Core Ultra 9, Core Ultra 7 is good enough. And moving on to next topic. It's Core Ultra 7 versus AMD Ryzen 7. And let's go. When comparing the Intel Core Ultra 7 to AMD Ryzen 7 9800X3D, comparing Intel AMD, especially for tasks like AI image generation and 3D rendering, it's essential to consider their architectural difference and performance matrix. And move on. Is architectural overview. Intel Core Ultra 7, the core threads. So Intel Core Ultra 7 has more core. 16 cores, 8 cores, and threads, 22 threads Intel, 6 performance core and 10 efficiency core. And base boost clock seems like Ryzen 7 is faster. Intel 3.8 GHz base. But boost is faster, up to 5.5 GHz boost on Intel Core Ultra 7. And Ryzen 7 base is faster, but boost is not that fast compared with Intel, but almost same. 4.7 GHz base, up to 5.25 GHz boost. And cache is the difference. Intel Core Ultra 7 30 MB cache, and Ryzen 7 96 MB including 3D cache. Including 3D cache would be something helpful for gaming, and what is almost same, 120 and 125. Architecture RX Zen 5 with 3D cache. Right. Performance in AI generation. AI image generation tasks such as performed using stable diffusion, primary leverage the GPU's capability. Leverage. So it depends on GPU. When using stable diffusion, GPU will be the bottleneck. Better GPU, better result. However, the CPU plays a supporting role in data processing and managing workloads, while specific benchmarks comparing these two CPU in AI image generation are limited. The higher base clock and substantial cache of Ryzen 7 9800X3D may offer slight advantage in scenarios where CPU performance becomes a bottleneck. So, I see. AI image generation. For AI image generation, Ryzen 7 slight advantage in where CPU performance becomes a bottleneck. But generally speaking, GPU will be the bottleneck, and better GPU, better result. Right. Next, performance in 3D rendering. In 3D rendering application, both CPU demonstrate strong performance. Intel Core Ultra 7 is hybrid architecture, combining performance and efficiency. Core provides versatility in handling diverse tasks. AMD Ryzen 7 9800X3D. The significant 3D void cache enhances performance in cache-sensitive application. including certain rendering tasks in Adobe Photoshop. For instance, the 9800X3D matches slightly surpass other high-end processors, indicating robust content creation capabilities. For gaming performance, while gaming may not be the primary focus, it's noteworthy that the Ryzen 7 9800 X3D excel in gaming scenarios. It offers superior performance, particularly in HD resolution, making it preferred choice for gaming it's for me it's hard to pronounce. Power efficiency. Processors have similar TDPs. The what, right? This real-world power consumption will depend on workload system configuration. So power efficiency is same. Conclusion. For AI image generation, the difference between these CPU are minimal, as this task is predominantly GPU demand. For 3D rendering, both CPU are competent, so the Ryzen 7 9800X3D's large cache may provide advantages in specific applications, but the Core Ultra 7 hybrid architecture offered flexibility across various workloads. Ultimately, the choice between two should consider budget, application requirements. Alright, great. All these. So.
Intel finally released fixes for the new Core Ultra processors, so is the 285K now worth buying? In this video we are going to find out. My name is Matt, I'm a former rocket scientist, and my goal is to help you make the right component choices and put them together the right way every single time. In the UPC FC series, we've been helping you make the right choice by pitting two components against each other in the PC octagon to see who wins. In this video, our focus will be on the Intel Core Ultra 9 285K and how it compares to the current king of gaming, the Ryzen 7 9800X3D. In addition to showing you benchmarks across 18 games, I will also outline the recent fixes from Intel and show you how they impact performance. And if you stick around, I'll share with you my pro tips for how to unleash the performance locked inside the 285K, something you will not want to miss. It's really not rocket science, so before the main event gets started, let's jump straight into the recent improvements made by Intel. Intel introduced the Core Ultra 200S series or Arrow Lake desktop processors on October 10th, 2024. Unfortunately, the gaming performance that they showed in their launch presentation was somewhat lackluster. This was rapidly followed by a launch on October 24th that, to put it mildly, did not go well. Most day one reviews highlighted significant problems and showed performance well below what Intel had shown. Shortly after the launch, in what was a somewhat refreshing turn of events, Intel's VP and GM Robert Hallock went on the record with Hot Hardware and stated that Intel had screwed up and promised to rapidly fix the issues and improve performance.
But we've identified a series of issues, multi-factor. They're at the OS level, they're at the BIOS level, and I will say that the performance we saw in reviews and to be very clear, through no fault of reviewers, was not what we expected, not what we intended. The launch just didn't go as planned.
There were a large number of problems at launch, with increased memory latency, BSODs, and a broken application performance optimizer, all contributing to a significant loss in performance. Post-launch, Intel conducted an investigation and determined that there were 4 distinct issues that were impacting performance. The first was a missing performance and power management, or PPM package. The second was the Intel Application Performance Optimizer, or APO, not functioning correctly. The third was BSODs when attempting to launch game titles utilizing the Easy Anti-Cheat service. And the fourth was select performance settings being misconfigured with the launch BIOS. The good news is that many of these issues were addressed in recent weeks via Windows and motherboard BIOS updates, and Intel is now working on a new range of performance optimizations. The bad news is we'll have to wait a little longer for this new microcode to be released. First, the processor power management, or PPM package in Windows, was not fully optimized for the new Core Ultra 200S processors due to Intel releasing an update to coincide with retail availability of the products, leaving reviewers with generic PPM profiles in their systems. According to Intel, missing, incomplete, or malfunctioning PPM can affect CPU frequency, core parking, C-state latency, and memory latency, and they estimated that this issue impacted performance anywhere from 6 to 30% in the day one reviews. Furthermore, Intel's Application Performance Optimizer, a software-level feature that ensures demanding tasks are sent to high-performing cores on a CPU, was not functioning correctly. That means that game threads were likely sent to lower-power E cores instead of being prioritized and sent to higher-performing P cores. This issue was fixed in later Windows 11 builds, which, according to Intel, could add up to 14% more performance in supported games. This confirms what I found in my 265K review and shows why you shouldn't trust content creators that blindly used APO in their day one reviews. And finally, Intel worked with Epic Games to distribute an updated anti-cheat driver to fix a blue screen when attempting to launch games using anti-cheat software. They also worked with motherboard manufacturers to fix default BIOS settings to optimally configure options such as resizable bar, compute tile ring frequency, memory gear ratio, and power limits. Intel estimates that these BIOS changes will result in a 2 to 14% improvement in performance depending on the application or BIOS setting responsible. To see the impact of these changes on performance, I decided to retest my Core Ultra 7 265K in 5 popular titles: Total War Warhammer 3, Cyberpunk 2077, Microsoft Flight Simulator, Call of Duty Modern Warfare 3, and Black Myth Wukong. For the Gigabyte Z890 Aorus Master that I used to test the 265K, I compared the new BIOS F10i against the old BIOS F10e, and I updated Windows 11 to the latest version. As you can see from the results for Total War Warhammer 3, there was a small increase in performance. For Cyberpunk 2077, the increase in 1% lows was good, but the average FPS didn't change. However, for Microsoft Flight Simulator, the 1% lows increased by a whopping 72%, which is crazy. I retested this game multiple times and got the same result, so this appears to be genuine and a very welcome improvement. For Call of Duty Modern Warfare 3, the 1% lows increased by around 9%, with a small reduction in average FPS. And in Black Myth Wukong, the 1% lows actually decreased by around 10%, which is definitely not good. As you can see, the performance impact was not consistent, which is somewhat difficult to explain, so hopefully future firmware updates will fix this. Intel identified a number of new microcode optimizations that will further enhance performance, claiming single-digit increases across 35 games. These performance enhancements will be enabled by a new firmware that is currently undergoing validation prior to customer release, with release anticipated in the first half of January 2025. The BIOS versions to watch out for are those that include microcode 0x114. Hopefully these optimizations will finally help resolve the gaming performance issues that have plagued the Core Ultra 200S processors since launch. As mentioned earlier, the battle today is between two top CPUs, with the Intel Core Ultra 9 285K in the blue corner, taking on the current king of gaming, the AMD Ryzen 7 9800X3D in the red corner. The test systems being used to run the benchmarks are my Intel Arrow Lake and AMD AM5 open bench tables with the following components. For the Intel Arrow Lake test platform, for the motherboard we have an MSI Meg Z890 Unify X. For the RAM, we have G-Skill Trident Z5CK 48GB of DDR5 9000 at CL42. For the RAM cooler, we have an OLS-I C-RAM dual fan memory cooler. For the GPU, we have an Asus ROG Strix GeForce RTX 4090 OC Edition. For the CPU cooler, we have a Corsair iQ Link H170i RGB 420mm AIO. For storage, we have a 4TB Samsung 990 Pro NVMe Gen 4 M.2 SSD. And for the PSU, we have a Be Quiet Dark Power Pro 12 1200W 80+ titanium power supply. For the AMD AM5 test platform, For the motherboard, we have a Gigabyte X670E Aorus Master. For RAM, we have G-Skill Trident Z5 Neo RGB 32GB of DDR5 8000 at CL38. For the GPU, we have an Asus ROG Strix GeForce RTX 4090 OC Edition. For the CPU cooler, we have an EVGA CLCX 360mm AIO. For storage, we have a 2TB SK Hynix Platinum P41 NVMe Gen 4 M.2 SSD. And for the PSU, we have an Asus ROG Thor 1200W Platinum 2 power supply. Affiliate links for all of these components are listed in the description below. All testing was performed with the RTX 4090 at default clocks. I used Thermal Grizzly graphene cryo sheets for each CPU, and I applied a number of performance enhancing tweaks, which will be covered in detail later in the video. For the 9800X3D, I used a kit of DDR5 8000 CL38 Expo RAM with the primary timings lowered to CL36 48 48 98. I also set the FCLK equal to 2000 MHz, so that the clocks are fully synchronized. For the 285K, performance scales with memory speed, so I used a kit of DDR5 9000 CL42 CUDIM RAM in Gear 2, which means the memory controller is running at half the RAM speed. As I explained in my 265K video, the Arrow Lake memory controller is exceptionally good. In fact, it's so good that it's capable of reaching frequencies high enough to start making Gear 4 a viable option. Previously, in almost every scenario, it was best to remain in Gear 2, as the latency hit was so bad that it didn't make up for the gain in bandwidth. With the introduction of Arrow Lake, however, we can achieve similar performance by running DDR5 8600 in Gear 2 or DDR5 9733 in Gear 4, which opens up the possibility for even faster DDR5 memory options in the future. To show just how much of an impact higher speed RAM has on the 285K, I decided to test a kit of DDR5 9000 against a kit of DDR5 7200 in 5 popular titles: Total War Warhammer 3, Cyberpunk 2077, Microsoft Flight Simulator 2024, Call of Duty Black Ops 6, and Black Myth Wukong. As you can see from the results, there was a huge 44% increase in the 1% lows for Total War Warhammer 3, a 6% increase in 1% lows for Cyberpunk 2077, and a 9% increase in the 1% lows for Microsoft Flight Simulator 2024, which is fantastic. However, for Call of Duty Black Ops 6 and Black Myth Wukong, 2 games that are GPU bound, even at 1080p low settings, the increase in performance was negligible. So when the game loads a CPU, you will see a large increase in the 1% lows, but when the game is heavily GPU bound, you won't, which makes sense. In order to thoroughly test the CPUs, I ran the benchmarks at different game settings, in addition to different resolutions. To place maximum load on each CPU, I tested at 1080p with low settings, which should allow me to extract max performance from each chip. To create a more balanced CPU-GPU load, I tested at 1440p with medium settings. And to see if each CPU had any impact on GPU performance, I tested at 4K with ultra settings. These resolution setting combinations align well with typical gamer selections, with 1440p medium settings reflecting what most online first-person shooter gamers would likely use to achieve maximum frame rates, whereas 4K ultra settings reflect what most single-player gamers would do with a high-end CPU-GPU combination to extract maximum quality. With the CPUs ready to go, let's check the benchmarks. But before we do, I think it's only appropriate to introduce this the right way. Over to you, Bruce.
And now, it's time! Introducing the components fighting for Blackbird PC Tech benchmark supremacy. In the red corner, we have the champion. In the blue corner, we have the challenger. Who will win this battle royale? Stay tuned to find out.
So blue is Intel, AMD is red. Blue, Intel, AMD, red.
Surprisingly well against a 90. As you can see from the benchmarks, a 285K performs surprisingly well against a 9800X3D. So the question that I'm sure many of you are asking is, how do you unlock this performance? As with my previous video on the 265K, there are a few important BIOS tweaks that you will need to make in order to unlock the true potential of the Intel Core Ultra 9 285K. The first is to install a kit of high-speed RAM and turn XMP on. As I explained earlier in the video, the memory controller for Arrow Lake is exceptionally good. For my MSI Meg Z890 Unify X motherboard, which is a 2-DIMM board that is specifically designed for enhanced memory overclocking, I was able to use a kit of DDR5 9000 QDIMM RAM in Gear 2. However, the motherboard that I used to test the 265K, the Gigabyte Z890 Aorus Master, is a 4-DIMM motherboard that wouldn't boot with memory speeds above 8800. So I wouldn't recommend anything above 8800 megatransfers per second for 4-DIMM Z890 motherboards. Since turning on XMP overclocks your memory, there is no guarantee that these speeds will be stable even with a QDIMM kit, so I strongly encourage you to run a memory stability tool like Kahoo to check. If your system is unstable, you can try increasing the DRAM VDD and VDD-Q voltages by small increments to see if it helps. You may also have to tweak the memory controller voltage as well. In addition to turning XMP on, you should also consider adjusting your memory subtimings. You can watch someone like BuildZoid on actually hardcore overclocking to learn how to do this manually, but most motherboards now come with automatic memory tweaking options that usually do a decent job. In addition, a subtiming tweak that helps boost performance and reduce system latency is to increase the TREFI to 65535. This will work on most CPUs and is a common tweak used by pros to help extract max performance from a system. After you are done tuning your RAM, I would again highly recommend running a memory testing tool like Kahoo to make sure that your memory is indeed stable. In addition to installing high-speed RAM, you should also consider overclocking your CPU cores. Overclocking your CPU is highly silicon dependent, so the fastest way to determine a good overclock is
this kind of setting is for beginner like me, it's too complicated and I don't want to make some huge mistake. That's why I'm afraid. Alright.
is to use the Intel Extreme Tuning Utility, or XTU. I like this tool because you can rapidly make changes directly in Windows, thereby avoiding having to reboot into BIOS every time you make a change. When you go to the Intel XTU download page, make sure you download version 10.x or later, which supports the new Intel Core Ultra processors. Intel, for some unknown reason, decided to list it second on the download page to make things just a little more confusing. When you first load XTU, you will be presented with the basic view. I would recommend starting with your efficient cores for Arrow Lake CPUs. Based on my testing, I've found that increasing the E-core frequency will give you a relatively large increase in performance. You can use the built-in benchmark to baseline your system, however, I've found it to give somewhat inconsistent results with each run, so if you do plan to use it, I recommend running it 3 times and taking an average. You can then increase the ratio by 1x and rerun the benchmark. You are looking for best performance, not the highest ratio that will run stable. So when you notice that the scores start dropping, then you should go back to the previous ratio, which should be your optimum. For your performance core or P-core ratio, I recommend switching to the advanced view. The reason I recommend doing this is that the ratios are different depending on how many P-cores are active. I recommend tuning the 3 to 8 active core ratio first before tuning the 1 to 2 active core ratio. Again, this is highly silicon dependent and you're looking for max performance and not max frequencies. They will very likely not be the same. Once you find an optimum, I recommend running a more comprehensive tool like Cinebench or Ada64 to see if your system is stable and how much your performance actually increased. I can't emphasize enough that these tweaks are highly dependent on silicon quality, so it can take some time to tune your system properly. After you find your optimum ratios in XTU, I recommend resetting the tool to default values and entering the new ratios directly in BIOS. For the MSI Meg Z890 Unify X motherboard that I'm using in this video, you can input your E-core ratio on the overclocking page under E-core ratio. For my 285K, I found 49x to be optimum. For the P-cores, you can select turbo ratio next to P-core ratio apply mode so that you can adjust each core. For each of the 8 performance cores, you can enter in the ratios from XTU next to target P-core turbo ratio group X, where X is the core number. For my 285K, I left the first 2 active cores at 57x, but I increased the 3rd to 8th active cores to 55x. As you can see, these are not large frequency overclocks, and my 285K was stable at higher frequencies, but these tweaks provided me with my largest increase in performance, which is what matters most. After you're done tuning your CPU cores, you can go back into XTU, click on Advanced View, and then click on Cache at the top. You can then adjust your processor cache ratio, often called your ring ratio. Once you find an optimum with the built-in benchmark tool, I recommend running a tool like Cinebench or Ada64 to make sure that your system really is stable. After you find your optimum in XTU, I recommend resetting the cache to the default value and making this change directly in BIOS. For the MSI Meg Z890 Unify X motherboard, you can input your processor cache ratio on the overclocking page under ring ratio. For my 285K, I found that 40X provided the best performance. You should also overclock your NGU or next generation Uncore fabric and D2D or die-to-die interface. You can adjust your NGU ratio in XTU by clicking on the other tab and adjusting the SA fabric ratio. However, I would recommend simply adjusting them both directly in BIOS. The NGU default ratio is 26x, while the D2D default is 21x, but I found that you can push them both much higher without impacting system stability. For the MSI Meg Z890 Unify X motherboard, you can input your NGU and D2D on the stream settings. This effectively changes the PL2 from 250 watts to 295 watts and on and off. At this point, you may be asking, what about Intel APO and undervolting your CPU? Let's start with Intel Application Optimization, or APO, which is a Windows app that optimizes thread scheduling for selected game titles. As mentioned earlier in the video, Intel acknowledged that the APO was not functioning correctly with Core Ultra 200S processors, but that the issue has since been fixed in later versions of Windows. So I decided to try it with Total War Warhammer 3, which is a supported game, but as you can see from the results, it does still not appear to be working properly. Given this data, combined with my prior experience testing APO extensively with my 265K, I decided to not conduct any further testing. It's simply not a tool I can recommend using at this time. With respect to undervolting, I tried using the core voltage offset option in XTU. It requires you to first disable hypervisor in Windows and undervolt protection in BIOS, but on processors. So in summary, the tweaks that I recommend making to extract max performance from your Intel Core Ultra 9 285K are: 1. Install high-speed RAM, turn XMP on and adjust memory sub-timings. 2. Overclock performance and efficient cores. 3. Overclock ring ratio, NGU fabric and D2D interface. And 4. Set power profile in BIOS, set power plan in Windows and turn memory integrity off. The impact of these tweaks on performance is summarized in this table. I used Cinebench R24 multi-core as the benchmark, and I turned on each tweak individually so I could show its impact on performance, starting with the smallest and ending in the largest. When implemented together, the boost in performance is around 8%, which is significant. As you can see in the table, one of the largest increases in performance came from overclocking the E-cores, which is video. One important point to re-emphasize is that the performance boost that you're able to achieve will be heavily dependent upon silicon quality test. In this video, we pitted two top CPUs against each other in the PC Octagon to CD, with 10 wins, 4 losses and 4 draws across 18 hard-fought rounds. When you look at the performance across 17 games, you see that the 285K loses the 1% low battle, especially at lower resolutions and game settings, where games are more heavily CPU bound. As the games become more GPU bound, however, it's able to not only match the 9800X3D, but beat it in average FPS by around 5%, which is quite impressive. If we now look at professional workloads such as Blender and 7-Zip, the 285K dominates with advantages of over 50%, which is not surprising given the much higher core count. The good news with the new Core Ultra 200S processors is that this performance comes with significant improvements in efficiency, with the 285K able to beat the 9800X3D in 3D Mark time spy, while losing to it in Cinebench by a similar margin, or 46% more expensive than the 9800X3D DDR5 8000 combo. If you convert that into gaming value, or FPS per dollar at 1080p, then the 9800X3D provides a knockout blow by offering over 60% better value in gaming when compared to the 285K, which is obviously great for Intel. With that said, these results do offer up some interesting choices. On the one hand, if you're building a new gaming focused system and you want the very best, then based on these results, I would recommend buying a 9800X3D. If you can find it. It's a truly amazing gaming chip that offers outstanding performance at an equally great price. However, if you do a lot of professional workloads in addition to gaming, and you believe that Intel will indeed improve gaming performance with their next firmware update, then the 285K might be an attractive option. It will unfortunately cost you more, and availability of the 285K is not that much better than the 9800X3D, but it might finally offer Intel fans a compelling reason to upgrade. I was actually quite impressed with how competitive the 285K was in these tests. The only thing really letting it down is the price, which is something Intel can do something about. Hopefully they can come through with their new firmware update in January, because as things currently stand, AMD is dominating PC gaming. Remember, it's not rocket science, it's Lego. My
Right. And I want to know more about the Ryzen 9 9950 X3D in real world. So that's the information so far. What's your choice? And what's your use? And what's your choice? That's it varies because of the purpose and choice. So if you use it for gaming, AMD will be best choice for performance and price. And for AI and editing some 3D or like something like Blender kind of things, Intel Core Ultra will help, and in future it will help more because of the software and OS optimization. What's your choice? Please write on the comment, and I want to know what's your choice and what's your recommendation. I'm still finding best choice for next PC. Thank you for watching.